Alright, welcome back, and this is part 2 of the Pioneer VSX-9700S audio video receiver. When we left off last time, we were looking for some parts to go in our center channel after it had a meltdown, and I was able to score some good used ones from my friend's shop out of a similar model Pioneer receiver. And I was also able to get my hands on some schematic information off of Hi-Fi Engine over the older brother and little brother of this receiver, the VSX-9700 and the VSX-9500. So we'll take a look at that. I got a schematic for the power supply and got one for the center channel. And we'll just kind of take a glance at that to kind of see what we're dealing with. And then we'll get the parts installed and see if we can get our center channel back in operation. So stand by for that.
So many times I call your name. Yeah. Before the night is through, let me wander with sweet soul inside of me, an everlasting kiss.
All right, coming back and taking a look at the parts that we needed, which was the 2SA-1263 and the 2SC-3180. Original Toshiba transistors, and what I was able to get a hold of out of a similar Pioneer model was a 2SA-1265 and a 2SC-3182. Now these transistors do carry a little higher ratings on them. I believe the pair that are original to the unit are around 40-50 watts, whereas these are about 70 watts. But just matching these up spec-wise, they should be fine. They should work okay. There shouldn't be any trouble there. That unit also had the IC we need, the UPC-1270H. So instead of using the new one, we'll just use that bad boy. Also pulled the emitter resistor. Might as well change that since all the parts were handy there. So we shouldn't have any issue with those. I got to looking on Hi-Fi Engine, and they have a manual for a 9500 and one for a 9900. And both those manuals contained schematics that the 9700 didn't contain. And the 9500 contained the power supply schematic, and I find it to be identical to the one that we're dealing with. The highlighted yellow lines take us in from the secondary of the transformer in through the two 6-amp fuses into the bridge rectifier, and this is going to be the plus and minus 38 volt line which runs that rear amp assembly. Now what I found strange is that the plus and minus 69 volt line, which runs the front channels, the higher power, there's no fuse protection coming into the bridge rectifier there. So I don't know if the idea is that if you have a spontaneous short, that it will trigger too much current pull and blow the 10-amp fuse, or you're just supposed to let it burn up everything in the front channel until it doesn't have anything left to burn up. Also, there's 5 regulators. I haven't seen but 2 in the 9700, but I'm sure they're all 5 there. A 5 volt, a 5.6 volt, a 12 volt, and a plus and minus 15. And that plus and minus 15 will supply voltage to all the op amps and switching ICs. Not all the switching ICs, but I'm sure there's some in that video section that would require the plus and minus voltage. So moving on to the center channel amp. It's very basic. There ain't much happening. There's our 2 transistors. There's our 2 transistors. The 1263 and the 3180. emitter resistor in between them. And then over here, I pulled this up just to look at this, the 2SC2458 transistor, thinking that that was some type of driver for the driver IC, but it looks like it may be something used for the bias of that after I looked up the schematic of that particular IC. But the reason I pulled up the schematic is just so you can see there's just not a lot going on here. There's not much happening at all. It's a very, very simple, straightforward amplifier design. So I'm hoping that because of that we shouldn't have any outstanding problems or nothing that we weren't able to detect in the first check. So we should be okay. So I'll get the camera set up, I'll get the board pulled back out, and we'll start installing the parts, and we'll see what we'll do a few checks beforehand and see if we can get the center channel going. So stand by. All right, got the camera set up for the overhead view here. I think the first thing, let's get that emitter out and we'll swap that. That one's pretty easy. Might get lucky and I can rock it out of there. Sometimes you take all the solder off and it just still kind of holds on, but not in this case. It fell right out into the receiver. So pitch that away. Doing these one-handed acrobatics here. There we go, that looks pretty good. And we'll wipe it off a little bit. Okay, now the IC. Looks like based on the others that the dot is pin 1, which makes sense. I assume that'll fall out as soon as I put the first dab of solder on it. So let's see if we can get a pin secured. Okay. Yeah, that looks okay. Now we'll go down to the other side. I don't think there was anything in that hole right there. looks all right. See if we can fill in those holes. Or not. There we go. All right, let's clean that up a little bit. That looks pretty good. It may have gotten a little higher on one side than the other, but that's okay. It's going to be upside down. Never even know. Okay, so next up, what we're going to do here, the last thing I want to happen is to install the outputs here, find out that the height is just a little bit off, and then have to go and redo it all. So I'm actually going to mount the outputs to the heat sink and then attach them to the board after I have all the other screws in the board. So now before we do that, let's put a little heat sink compound on that. Everyone has their own methods for doing this. Some people put a whole bunch. I just put what's needed. If you put too much, it's going to squeeze out the sides anyway. So okay. We know based on our markings on the board that this is the C and this is the A, so and let's lay this off to the side. And we'll just get it snug. We won't commit to like super tightening it down. That way if it needs to move left to right, it can. And these screws usually will fall back into their normal place. There we go. And see, we still got a little wiggle room there if we need it. Now we'll do the other one. Okay. Again, we got a little room there in case we need to move it back and forth. Now, as we bring this board in, but you know what? Let's throw some heat sink on those too, some compound on those too. one more. And of course the biggest trick of all is to do this without getting it all over your hands, which is a rarity for me. Trying to get fancy here. All right. Now, kind of get the other screws in position first. Instead of hunting for them later. Okay, now as we get up to this point, kind of just sink these into there. And then get our screws started a little bit, maybe. And that's the first one. That's the second one. So far, one has not dropped down into the unit, so that one's fighting a little bit. It doesn't. There we go. And then the last screw. And I'll be coming back around to tighten all these down. But for right now, this is what we want. Let's push a little bit. And then there's one screw that goes in the top here into that bracket. Snug that up. Now we'll kind of pull our pins like so and solder those up. Looks pretty good. Come back around and clean it up a little bit. Again, the whole cleaning thing is just a personal preference. It would work just fine with all the flux on it, but I just like to clean some of it off. I won't clean it all off, but I'll clean quite a bit of it off. I want to look at that connection again. It's like there's something right in between those two pins that is kind of standing out, but it could just be flux. Yeah, I think it's flux, but let's hit it again just to make sure there isn't any transient solder, maybe. Yeah, I think it's just the connection, the pad. Yeah, that looks pretty good. We'll hit it one more time with the cotton swab and the solvent. Yeah, that looks good. I'm good with that. Well, the important thing is don't drop these pieces that you're cutting off down inside the thing. That could turn out to be very bad. And at the end of the day, it looks pretty similar to the ones that's already there. All right, so let's pause here. I'll come back and we'll do some dead checking just to make sure everything kind of lines up with the channels that are working, and then we'll give it some juice and see what happens. Stand by. Okay, coming back from the break, I had a chance to tighten down all the screws that hold the outputs to the heatsink, and I used the funky looking L-shaped screwdriver for the front channel outputs and tightened those down too. Obviously this would have been a lot easier if I would have done that prior to putting that board back in, but obviously not thinking that far ahead. So I think what we'll do is let's just do a few dead checks on the channel we worked on. Don't anticipate any kind of a issue, but it will certainly let us know if there's been any kind of breach in one of the insulators on the outputs, or if we inadvertently solder bridged something together, which we don't believe we did, but we're just being cautious. Looks pretty good. And all we really want to do here is just kind of compare it to the channel that didn't take any damage and see what that looks like. And all those numbers are pretty much in line with each other. There's always going to be those variables. One output will age differently than another one, or one channel's components will age differently. And so there's going to be some variables. Let's look at the emitter resistor, the one that we put in. .7, 0.5, and 0.4, and 0.7, 0.5, and 0.4. Well, that lines up pretty well. Oops. There we go. Okay. So it all kind of jives. It all seems fine. We've done our due diligence to check through all the supporting circuitry and the resistors. We know all that seems to be okay. So typically, if this was a much more powerful amplifier and I was even slightly concerned about whether or not I may have missed something, whether or not there could be something unknown to me that could create an avalanching effect of the parts I just replaced, I'd bring it up nice and slow on the variac, looking for any excessive current draw. In this particular case, though, there's just not a lot of parts there. It seemed real clean. We pulled all the parts out. It fired up, came out of protect the way it's supposed to. So I think what we're going to do is just go ahead and throw some power to it. One thing we will do is let's look for DC voltage. This is the center channel output. We'll turn it on. Well, let's flip the receiver around. We'll turn it on and we'll look at that. If there's any DC there, if the relay clicks at all and sees the DC, it'll unclick immediately. If there is something catastrophic going on, the two 4-amp fuses that I have convinced myself are some sort of safeguard will blow immediately, but not fast enough to protect the parts that I just replaced. But we're pretty confident that we got everything, so power on. We should get the click, and we did. That's the center channel kicking in, 0.53 volts. That is DC offset, and that is high, but there's no way to regulate that. There's no adjustment for DC offset. There's no adjustment for idle current. So it just is what it is. And as a means of comparison, we know that the rear channel shares similar outputs, similar circuitry, actually identical. So let's make a comparison to the rear channel and see. That's the rear channel at 0.60, 61. So we know there wasn't any damage done to that. Let's go back to the center and double check. And 0.52. So we're right there in the ballpark of where we need to be. These type of receivers where they kind of govern, built-in governing device for the idle current, for the DC offset, and those type of things. It's never perfect. It's one of those things where it could be a little bit high or a little bit low, and if you're trying to make a comparison with the neighboring channel, you know, they just never line up. They're always just a little bit off. But this is well within what I would consider to be, you know, normal operating range for this. And lots of things affect that. Over time, the parts will age. They will get burned in. Tolerances will change in resistors. Tolerances will change in traces. Resistance will increase. And all that, a little bit of this and a little bit of that will affect that overall number. But I'm not seeing any red flags here, so let's hook a speaker up and see what kind of sound we get. And it should be, let's turn the relay off to the center channel. While we're messing around back here. Volume down, and let's turn her on. And what do we got for center channel volume here?
Classic Rock Q106.5 of the Big Rig. In the holly jolly season we are. The Festival of Trees is underway tomorrow. It's right after the holiday.
Reminding me again why I don't listen to commercial radio. I don't know. It seems perfectly fine to me, perfectly stable. It hasn't been on long enough to really make any kind of determination as far as heat, but it is extremely cool to the touch. So I think what we'll do at this point, let's let it burn for a little bit, pause the video, then we'll come back and kind of do a temperature comparison to see if everything's good temperature-wise. Maybe look at the idle current and see what that looks like. But other than that, I think it's done. So stand by for that. All right, that's been baking up for a while, and there is just no issue there. Temperature-wise, we're doing great. Idle current comparison to the rear channel, totally fine. A little bit higher with the one that we worked on, but that was to be expected. Substitute outputs and such. But it is not anything to be concerned about. But I did find another issue, and I wanted to hook the front channels back up and listen to those for a little bit, and when I switched the relay on, I had one channel but not the other channel. So checking the input from the bench for the CD player, that was fine. The speaker lines were fine. So I switched the relay off and switched it back on again, and the channel came back. So looking underneath the receiver, I could see the connections for that relay, and they were fine. There was no cold solder joint there. So unfortunately, there is going to be some loose or dirty contacts that's going to have to be taken care of there. So I'll take the relay out and we'll take it apart, and hopefully we can get it apart without cracking the case on it and get that fixed. But the one thing that I've obviously tried to blank out of my mind that's going to have to be addressed, and let me turn this off, flip the receiver around and we'll talk about it. I think I was trying to suppress the memory of having to do this. Off video, in between the clips, as anything I usually work on, what I'll do is I'll just go through and start checking random capacitors on circuit boards just to kind of get an overall baseline of the health to see where we're at. And certain things I don't need to do that. I already know that there's going to be a problem. And in this particular case, the power supply regulators, the ones that, in this particular case, these two are mounted to this heatsink. These get really, really hot. And I think the idea here was the engineers looked up the specifications of the regulators as far as temperature and what the maximum temperature that they would operate reliably at, and decided that, well, let's make the smallest heat sink we can and keep it at that temperature, because we just don't have enough room. There's a lot of stuff in this receiver. But anyway, these capacitors, are just heat stressed, and so after checking those, found those to only have about maybe 30-40% of what they really need to have, and so they're going to have to be changed, which would be nice if it was just the only two, but it's not. Underneath this circuit board, I know there's at least two more under there, and possibly the fifth one is under there. I'm not sure. I can't tell from the underside of the board, but I believe there's at least two more underneath there. And that board is the one that contains all these composite video jacks and the preamp jacks, and so that's going to have to come out. And then this top S-video board with the center channel speaker connector on it, that's going to have to come out. And then once we get that out, we can get access and change the bad caps. I mean, and these lines, plus and minus 15 volts, the 5-volt system control line, all these things need to make sure that they're reliable and hold up over time. So that is quite the task ahead of us. I think the first thing we'll do is let's fix the relay first. That's easy. And let's get that out of the way. and then we'll start dismantling, taking all them screws out and get everything, get the boards. Hopefully we don't have to take out too many of the connectors, and we can just move the boards aside. All we need is just access to be able to physically reach the part, maybe with a pair of hemostats, and get it from underneath. Another concern, obviously, and this particular one actually doesn't look as bad as many I have seen. A lot of times these connections will be so bad, the traces will be so bad that they're literally falling apart, but this doesn't look that bad. And so the discoloration, absolutely normal. Every one of these receivers I've ever seen, it was always discolored like this, but I've literally seen it to where these resistors are black and brown. Everything is baked, especially if they were to stack another component directly on top of this one and trap all that heat inside the unit. So we definitely want to pay close attention to the traces here when we're taking capacitors out. Don't want to have heat applied to this any longer than necessary, because I don't want to open up that can of worms where I'm trying to fix traces. So that's where we're at. I'll get the camera set up and we'll get the relay out. Luckily for me, that relay is the one that I can get to right there. It is not the one below it, which is the B speaker relay. And I'm not even going to hook a set of speakers up to the B speakers. I'm just going to assume that relay is totally fine and live in denial that it could have a problem, because there ain't no way I'm taking out this whole main board to get to that B relay. So we're just going to assume that's fine. But the A one, we definitely want to make sure that that's fixed, so we can get to the connections and get it out. So stand by, and we'll get that out and get that repaired. Okay, we have the relay out, and that turned out to be not exactly where I thought it was. It wasn't the one that was buried underneath the frame, but it was underneath one of the circuit boards. So I had access to the connections to get the relay desoldered, but its physical location was different than I thought it was. So there was a piece of tape they put around here, and caused some kind of residue to build up. So see if we can get the X-Acto under there one side, maybe. And get maybe a pick under the other side. That might turn out to be the hard part. These aren't the stiffest picks, and so. Okay, let's find another blade we can stick underneath there. Maybe. Try to do this without cutting my hand apart. There we go. That's it. Yeah, you can see the build up there. Okay. What I'm going to do is just take a very thin, fine file, and I'm going to spray it with some WD-40 and clean it that way. And then come back and clean off anything that may have been left behind. Until I can see it shining a little bit. And they're split. So try to be careful not to bend anything. Oh, there goes the furnace again. Those are looking pretty good. Those look pretty good. They need a little work, but not too much. This is a really fine file, so it's not really taking off any bulk of metal material from the contacts. It's just kind of burnishing them up a little bit. And then anything that I've left behind, I'll flush it out with the WD. Those look pretty good. Let me see. I guess a before and after would have been okay, but they're nice and clean. So now we'll flush it. This should do quite nicely. Okay. Just kind of soak up a little of the excess. We'll leave some of it there. Soak up a little bit. There we go. Looks good. And since we didn't, this is a pretty big thing. since we didn't split right there by prying too hard. Scraped it up a little bit, but we didn't split it, and it'll just click right back together. And it stays together, the top doesn't come off. So, all right, let me shut off the furnace over there, and then I'll show you the receiver taken apart, and we'll put that back in. Get my hands cleaned up just a little bit. I like the WD-40, but I don't like it all over my hands. All right, let's see. That should shut off pretty much any time now. Clean that up. I'm not sure why the tape is there from the factory, but we're not going to put any more tape on it. That is definitely not coming apart. That is sealed up, and that should take care of our needs here. All right, so now you can see the back panel removed, and we have access underneath. And this was the relay I have access to from the top of the board, but it's this one I have access to from the bottom of the board. So if I have to choose, I will take that one. This one here, again, B speakers, I'm not going to even mess with that. So we'll just leave that as is. There's a third relay there, which I believe that one is the rear channel, because the center channel relay is located on the board that has the center channel speaker out. So that's where we're at. And of course, this gives us pretty good access. We can dig through the ribbon connectors. There's the third regulator, and the fourth regulator is actually right here. And lucky for me, that 10 mic at 25 volt cap is in surprisingly good shape. There's a 1 mic at 50 right next to it that's in excellent condition. So, but I have not found the fifth regulator, so it's possible maybe this one doesn't use the fifth one. I don't know. So anyway, there's that and that. So let me get the relay put back in, and then we'll pick back up and look at our caps and see which ones we need to replace. So stand by.